Inside the U.S. Capitol building in Washington, D.C., there's an elliptical-shaped room called Statuary Hall. It is said that John Quincy Adams put his desk at one of the foci in the room so that he could hear other politicians whispering to each other near the other focus. If the room is 97 feet long along its major axis and 46 feet wide along its minor axis, find the distance between the foci rounded to the nearest foot. So effectively, we have a room that's shaped like an ellipse. And what happened was John Quincy Adams put his desk at one of the foci because people who were standing near the other focus who were talking would have their sound waves from their voices bouncing off the walls and all being reflected toward John Quincy Adams' desk. So this was a way that he could spy on people on the other side of the room. Now we know that the room is 97 feet long along its major axis and 46 feet wide along the minor axis. And so what we're going to do is we're going to put the center of this ellipse at the origin, just to make things easier. And here we know that the major axis is 97 feet long, and so the value of A is half of that, and half of 97 is 48.5 feet. And then for the minor axis, we know that the width is 46 feet wide, so half of that is going to be 23 feet. And so we can figure out the equation that models the room. It's going to be x squared over 48.5 squared plus y squared over 23 squared equals 1. Now what we were asked for is the distance between the two foci, and that distance is actually equal to 2 times c. Because remember, c is the distance from one of the foci to the center, but if we're looking for the distance between them, that's going to be 2c. So first we need to figure out the value of c, and then we need to double it. So we know the relationship between these quantities is b squared equals a squared minus c squared. And in this case, we're actually looking to get c alone. So we could get c squared on its own by adding c squared to both sides, which puts a positive c squared on the left, and then subtracting b squared from both sides, which gives us a negative b squared on the right. These are equivalent ways to write the same relationship, but we're looking for c in this case, so this is a slightly better way to do it. So we've got c squared equals 48.5 squared minus 23 squared. Now, using a calculator, 48.5 squared is 2,352.25, and 23 squared is 529. When we take the difference, that tells us that c squared is 1,823.25. And when we take the square root of this quantity, we end up getting that c is approximately equal to 42.6995 feet. Feet, of course, in this case, because we are measuring this in feet. And we can comfortably round this to 42.7 feet. However, that's the value of c, and we wanted to know what 2c is, so we've got to double this, and so the distance between the foci is twice this amount, and 2 times 42.7 is 85.4 feet. So the distance between the foci, which is the distance between John Quincy Adams' desk and the other focus in the room where the other politicians might be speaking, was 85.4 feet. And due to the elliptical shape of this room and the reflection properties, he was theoretically able to hear some of the things that they were whispering from over 80 feet away.